Okay, hello. This is Dr. Osman Al Hassan. I'm going to solve the quiz 1 that we did the last time. So I think it's about 2 months ago. We wrote our first quiz on applied electricity. So I'm going to solve quiz 1. I've also solved quiz 1 for MA for mathematical students. So I've put the solution online, meaning it's actually on YouTube. I'm going to be uploading this solution on YouTube, so you can watch this. Then if you have enough time, you go and watch the quiz 1 solution for MA 151. Okay, now let's start. Okay, now, so when you have question 1 here, if you look at question 1, okay, in total you can see that we have 3 questions, 1, 2, and 3. So I'm going to solve one after the other. So you can see that question 1 talks about charges, electrons, and then current. And then question 2, you are given a circuit diagram. You have to find the currents in the circuit diagram. And question 3, you have to find the power dissipated by the 3 ohms resistor. So question 2, I'm going to solve question 2 using mesh analysis method. Then 3, I'll be using superposition theorem. So this is to make sure that you are familiar with how to solve a circuit diagram program using any method, right? The different method that we are there. So I'll be solving other quizzes that I've conducted for the other programs. For example, for computer students and the cybersecurity students, I'm going to be solving them, and I'll be uploading everything on YouTube. So this will allow you to have easy access to the solutions. Okay, let's start with question 1. So I have question 1 here. Question 1. So question 1 here, you have a battery supplies a current of 4 amps and produces 72 kilojoules of energy for 2 minutes. What is the voltage of the battery? So you can see from this question, we start by writing the values of the parameters that are given from the question. You can see that we are giving current to be equals to 4 amps. Then we are also giving energy to be equals 72 kilojoules. So 72 kilojoules is going to be equal 72 times 10 to the power 3, which is going to equal to 72,000 joules. So you have 72,000 joules of energy that is in produce, and the time taken to produce amount is 2 minutes. So we have time to be equals to 2 minutes. So we are going to change this into seconds. So we have 2 times 60. That's going to give me 120 seconds, right? We have 120 seconds. Now we have to find the voltage of the battery. So with what we have been given, you can see that we are giving energy and then time. So energy and time here, I can try and calculate for the power, right? Because power is the rate of doing work. So energy is power is a form of energy, right? I mean, work done is a form of energy. So we can get power to be equals to energy over time, which implies power is going to be equals to, can say power is going to be, okay, come in, okay, so we are going to label this, okay, we are going to label this as equation 1, okay. Now we are going to write another equation for power, but this time we are going to be using the current and the voltage. So power can also be equals to current times voltage. So I'll label here to equation 2. So you can see we have power in both cases. So we equate equation 1 and 2 so that we get energy over time is going to be equals to current times voltage. Since we are interested in voltage, we make voltage the subject, so that will be equals to what? Energy over current times what? Time. So we get this. Now we just replace the values. So we have energy to be 72,000 divided by 4 times 120 seconds. So this 0 will cancel 0. 4 times 12, or maybe you can even say, okay, 4 times 12 is going to give me 1. 4 times 12 will be 48. So if we take inverse of 48 times 7,200, so you see that we get 150 volts. So this is going to be the power. The power going to be the voltage of the battery. So the voltage of the battery gives us 150 volts. Now we move on to the next question, which is 1b. Question 1b. 7 times 10 to the power 22 electrons have been transferred for 5 minutes. Find the amount of current flow in this time period. So we start by again, right, writing the values of the parameters we are giving. You can see that we are giving the number of electrons. So I can write n here to be equals to 7 times 10 to the power 22 electrons, and then we are giving also time. So time here going to be transfer. Time of transfer is 5 minutes. So again we change this to 1 second, so that will be 5 times 60 seconds. So time here is going to be equals to 300 seconds. Okay, that's the time. Now we have to find the amount of current flow in this time. So we know that current is the rate of flow of charges. So meaning it's going to be charged over what time. So you can see here we are given electrons. And if you look well, you can see that question B, you are being provided with what? The magnitude of what? The magnitude of charge of 1 electron. So 1 electron is going to have 1.602 times 10 to the power minus 19 coulomb of charge. Okay. Now, if we are having 7 times 10 to the power 22 electrons, right? So how many of charge will I have? So with this we cross multiply. So we get this to be equals to 1.602 times 10 to the power minus 19 times 7 times 10 to the power 22, and this is going to give me so what do I get for this? So if you were to multiply, you can see that you can just multiply 1.7. So if you multiply 1.602 by 7, that will give us 11.214. Now this on the power, that will be 10 to the power 3 coulombs of charge. So we have near 19. Minus 19 plus 20 will give us 10 to the power 3. So this will be the charge. Now we can go ahead and calculate the current, which will equal to the charge 0.214 times 10 to the power 3 divided by time, which is 300 seconds. So we have this times 10 to the power 3 divided by 300. So this is going to give me 37.38 ounce. So we get this for the current. Okay. So this means that if you have 7 times 10 to the power 22 electrons have been transferred from this, that will produce a current of 37.38 amps. Now we go to question 2. We have question 2 here. Question 2. Calculate the current in figure 1. So if we are given figure 1, instead of figure 1, we have to find the current. In this question, I'm going to be using mesh analysis method to solve for the current. I want to use mesh analysis. So using mesh analysis. Okay. So in using mesh analysis, we are going to assign the current to a loop. So I'm going to sketch the circuit diagram, figure 1. So we have 30 volts. Okay. 30 volts here. Then I have 4 ohms. Then we have 5 ohms. Then I have 6 ohms here. Then we have 2 ohms. So this is a circuit diagram. So with mesh analysis method, what we tend to do is that we are going to assign current to each loop. So let's say this is loop 1 to each independent loop. So I have 2 independent, which is 1 and 2. 2 here. So each loop we assign current. So I'm going to assign I current here, but I'll label I1. I have assigned current here, I2. So I1 here and I2, we refer to them as mesh current or loop current. Once I've done this, the next stage is now going to indicate the polarities of the resistors in the circuit diagram with respect to the flow of current. So if I have current here flowing, this is loop 1 current, so it's all the current going through all the resistors in loop 1. So I have plus minus here, plus minus, same here, plus minus. Okay. Now when you come to loop 2 current, you can see it goes through what? The 6 ohm resistor. So here plus minus 1, plus and minus, here also plus minus, plus minus, plus. So now that we've done this, the next thing we just to apply Kirchhoff's voltage law to loop 1. So we are going to be moving clockwise like this. So the law just actually says that the algebraic sum of what? Voltage in a closed loop is 0. So if we were to do the algebraic sum of the voltages in loop 1, we should get 0. So we are going to do the algebraic sum. So here I have minus plus. So I have here minus plus, that is right. So 30 minus. It's plus minus is dropped, so I have minus. But because you can see I2 is also going through I4, so we take the difference. So we get 4, which is I1 minus I2. Because we are what? In loop 1, so I1 is a dominant loop. So that one, dominant loop minus what? The less dominant loop, right? Or the non-dominant loop. So 5 here will also be equals to I1 minus I2. And then we have this one, which is 2I1 equals to 0. So we have this. So if we were to simplify this part, right? If we go ahead and simplify, so we go ahead and simplify equation. This part, what we are going to get, when you simplify this, you are going to get, at the end of the day, you get here to be when you get it to be minus 11 I1 plus 9 I2 equals to 0, and this is just by, alright, you get this. Now, okay, where's minus 30 here? You bring minus 30, so it will be minus 30 here. Minus 30. So we have this. Now we take this across the equal sign. That 30, you get minus 30 here. Now this we label this as equation 1. Now this is our equation 1. We are going to get equation 2 by applying Kirchhoff's voltage law to loop 2. So I have my loop 2 here, we're applying. So here too, we are starting from this one, the voltage across the 6 ohm resistor, then we are coming back to this end. So here we get a drop, so we have minus I2 minus 4 I2 minus I1, because I2 is now the dominant loop, like loop 2 is now the dominant loop, so we get here 5 I2 minus I1 goes to 0. Now with this, again, you simplify this. When you simplify, you are going to get 9I1 minus 15I2 equals to 0. So we make I1 the subject, so that will give me 15I2 over 9. Right, so level here equation 2. Here now equation 3. Now we can substitute what equation 1, equation 3, equation 1, and solve for one equation the I2. So if we should get minus I 15I2 over 9 plus 9I2 is equals to minus 30. And when you solve this, you will get get I2 to be equals to 270 over 84, which is going to be equals to 31214 amps. So we get this thing to be the current for I2. Now let's go and get the mesh current, calculate mesh current I1. We wrote earlier, I1 is just going to be 15 times 3.214, because that's our I2 divided by 9, and that will give me 5.357 amps. So this is our I2. Now, once you've gotten it, the next stage is now to come and indicate the current, right? So we're going to now assign current to each branch. Okay, so I have here I1, and I'm going to label here to be I3, and here we'll label at I2. So if we were to do this, we are now finding the branch current, or you can call it the red current. So with this, you can see that I1 here, right? The current which is passing through the 2 ohms is I1. And then when we go back and look at the equation, the loop current that we get. See, the loop current I1 is the one that's also going through the what? 2 ohms here, right? So as a result, you can see that for the branch current I1 is going to be equals to the mesh current I1, which is 5.357 amps, right? Then I2 here, the same thing, similar to I1. You go back, you can see that I2 is the loop current that is passing through the 6 ohms resistor. So we have here, like here. So I2, the loop current is passing through 6 ohm resistor here. So I2 we can equals mesh current I2, which is 3.0214 amps. So we get this as I1 and I2. Now I level what I3. So in trying to get I3, we come and what indicate the node here. Here we have a node. So you have, let's say, node A, right? So at this node, based on the direction of the current I've indicated, you can see that I1 is entering, I3 and I2 are leaving. So I can write this equation, I1 equals to I2 plus I3. So if you make I3 the subject, we are getting I1 minus I2. So I3 simple put is going to be equal to 5.357 minus 3.214 214. And when you subtract this, you are going to get 2143 amps. So you can see that I1 is what, 5.357, I2 3.214, and then I3 is 2.143. So that's for question 2. I move to question 3. Okay, move to question 3 here. Question 3. Question 3, you have to find the power dissipated by 3 ohms resistor with the current source of 4 ohms. So this just means the current source here is actually 4. So I can label that one here. This question, we are going to solve it using superposition theorem. Superposition. Theorem. We're using superposition theory to solve this. Now, so we have to find the power. So the power dissipated by 3 ohms resistor will be equals to the current that is passing through the 3 ohms resistor square times its resistance, which is 3 ohms. So to solve this, I have to first calculate for the current. And to find this current, this is current, we'll label at 3 ohms resistor. This current is going to be equals to the algebraic sum of what? The current due to the 24 volts acting alone plus the current due to the 4 amps acting alone. That is the superposition theorem, right? So if you have current passing through an element, the algebraic sum of the current is going to be equal to the algebraic sum of the current due to each voltage source acting alone, right? So if you have a situation whereby you have 2 or more sources, right, or 2 or more independent sources, you can see here we have what? A voltage source and a current source. So we are going to get the current due to 20 volts acting alone, and then the current due to 4 amps acting alone. So let me start with trying to get the current due to 20 volts acting alone. So to find this current, so I have to come here, only 20 volts is going to be in operation. So the other source, which is current source 4 amps, I have to make that place 0, and to make that place 0, the current to be 0, meaning you do open circuit, you open this, and you just remove the current source. So once we've done, you get something of this nature. You can see I just remove the current source so that the current flow there is 0. So with this, you can see that if you have current I that is going through the element in the circuit, you can see that it will go through 3 ohms. 5 ohms here is open, so no current flow there. Can just also pass through and come to this. So you can see that because of this, the current due to the what? Due to the 20 volts acting alone acting alone is simply going to be equals to 20, right, over this one current is there, so the current pass through 3 ohms and 10. So 3 ohms and 10 are in series, so you do the sum, so that will be over 1, 3 plus 10, and this will give us 1.538 amps. So we get this. Now you go and try and find the current due to what the 4 amps acting alone. So again, we are going to make the other source to be 0, and since here we are dealing with a voltage source, to make it 0 we short circuit, so meaning you just connect a wire, and as a result the voltage there becomes 0. Then we have this, then you repeat everything else, bring your 4 amps here, then I have here to be 10 ohms, and then 5 ohms. So you can see that I'm interested in the current that is passing through 3 ohms resistor here, right? The current that is passing through this. And you can see this current, which is 4 ohms, is actually going through 5 ohms. And once it gets here, this is 4 amps, is going to be divided, right? So to get the current that is passing 3 ohms, you can see that it's just going to be equals to, in the current due to what's passing through 3 ohms due to 4 ohms acting alone, is going to be equals to the other resistor, which is 10, because 10 and 3 ohms are what, in parallel, over the sum 3 plus 10 times 4, and this will give me give us 3.077 amps. Now we come and do the algebraic sum. So the current passing through the 3 ohms will be equals to, again, here is the algebraic sum. You can see that you can come and indicate here. When it comes to the direction, the first current is passed going this from left to right because of the voltage source here, and the second one is going to be coming this way. So you can see that we have the currents being in opposite directions. So as a result, when we are doing the algebraic sum, we are going to take the from left to right to be positive direction and the opposite to be negative. So I'm going to write here. So the positive direction is going to be my this current here, because you can see passing here. So me over 1.53. So I'm going to have 1.538 minus 3.077, because it's opposite to it, and this will give us minus 1.5. Five 39 amps. So we have our current now. The power is going to be equals to that's 1.539 square times 3. That will give us 7.106 watts. So this is our final answer. And these are the current. And the current here. And then the last current.